Hello civil engineers, welcome back to this lecture. So here we'll try to see how the BBS for this particular beam has to be done. So first you need to understand what they have written. They have written a top bar here. See, this is top straight bar. Then this is top left extra. This is top right extra. And this is bottom bar, bottom and bottom straight. Got it? So this is how now we are able to understand when I say top straight means that straight bar, extra means left extra means right extra, and this is bottom straight bar. This extra I'll explain you later what it is. Okay, this much is understood. Now after that they have written 1 and 2. They have written 1 and 2. What do you mean by 1 and 2? 1 and 2 means usually when you put the bar, for example, if I draw a cross section of a beam, so if this is my beam cross section, okay, if I put a bar only in one layer, so if I put a bar only here and only here, this is top bar, and bottom if I put bar, so this is my bottom layer. So in the bottom this is first layer, okay, and in the top this is first layer. So this first indicates that you are putting the bar in the top, you're putting the bar in the first layer, that is this is 16 diameter 2 bar. Similarly, you come to the bottom it is written first means this is first layer in the bottom, and it is 16 diameter 2 bar. Second means sometime when your beam is heavy, we'll see that also later part in the later. Sometime when your beam is heavy and you don't have space in the first zone, what we do, we try to give the reinforcement even in the second zone. So this becomes my second zone in the top. So this second you can see this part. This is in the top. Similarly in the bottom, if I put a bar like this and if I put a bar like this, so this will be my second zone number 2. So this is my zone number 2 in the bottom. Got it? So that is how it is. Now, if you understand, this is understood, no? Good. Now you tell me how this is going to look. So we'll be providing a section. If I draw a cross section of a beam, if I draw longitudinal section of a beam, yeah. So if this is my beam, so it's written and at the top, you have to provide a 16 diameter 2 bar. So I'll provide a 16 diameter 2 bar. So this is one bar which goes completely. So it's a 16 of 2. Got it? And in the bottom, I need to provide 16 of 2. Again, in the bottom, this will be my 16 of 2. Now you understood the concept? Good. Then after that, is there any top left extra? No, we don't have any top left extra here. Is there any top right extra? We don't have any top right extra here. I told you that won't come in all the beam. If your beam is having a less load, in that case, top left extra, top right extra won't come. Only bottom and top will come. Now come to the stirrup. In the stirrup, it is mentioned end and middle. End means near the support. So this is my end portion. So when I say end, this is my end portion. This is my end portion. So from this part, from here to here, this is my left end, that is ends. This is also my end. So here I am supposed to provide the stirrup of 8 mm at 100 mm center to center spacing. In the middle, the spacing is 200. So this is my middle. This is my middle portion. This is my middle portion. Now here I am supposed to provide 8 diameter at 200 center to center spacing. Understood? That's it. So if I had explained this in the initial stage, you would not have understood. Now you know what you mean by this. Now what we have to do here, now again this longitudinal section is not given. So when such drawing comes, you have to ask the AutoCAD draftman to create a longitudinal section and give. Else it's difficult to do a BBS of this. But still we can do from here. So what it is written, GB1, right? GB1 is ground beam 1. So come here. Where is your GB1? So this is my GB1, ground beam 1. So what I'll do, I'll start from here. I'll take a dimension of this. Already there is a dimension taken. Yeah, this is my GB1. This is my beam. This is my beam. My GB1 will go completely, okay? My GB1 will be going completely. How do I put this GB1? Because I don't have column. My GB1 will be resting on this only because even though it's a primary, yeah, it's a secondary beam. My GB1 is secondary beam. This is secondary. Then that means how this beam will be resting. First, you're going to put the reinforcement of this beam. Then the reinforcement of this beam will come. And after that, the reinforcement of this beam will be resting on this. You're getting my point? In that case, what I'm supposed to do, I need to take the complete length. So my distance will be from here to here. So what is the distance of that? That I need to come here, check the dimension. See, you don't have to worry. You don't have to worry because if you tell the AutoCAD draftman to give the longitudinal view of that, he'll give like this, like we did, no? He'll give you like this. He'll give you longitudinal view like this. You don't have to worry. But here, I'll explain you. That's it. Fine. So this is 4955. Now you have the length 4955 and you know how the bar has to be put. So based on that, you do the calculation. Top what you will do? 4955 minus 1. I mean, it will be like this, okay? You have to find first your bar will go like this. But I'll delete everything. You have to find like this. Yeah. First you put your bar up to here. This will be a straight portion bar where the length is 455. And from here, your development length will start. From here, your development length will start. It will go up to here, not completely. You'll take this length. This length will be your width of the beam minus cover. So this time, which cover you have to take? Beam cover. I mean, why beam cover? Because this beam is going in another beam. So it's not the column which is going. Actually, you have to take column. But in this particular case, it is resting on another beam. So the beam cover is 25 mm. So from here, I'll deduct the beam cover 25 mm. Got it? And from here also, I'll deduct the beam cover 25. Why? Because this is beam. This is resting on another beam. So if you're not able to understand, I think I have a better picture for that where I can show you that. Yeah, this is that situation. See, this is that reinforcement. This bar is resting on this beam. This end is resting on this beam. So the cover what you're giving in the beam is 25 mm. Whereas here it was column. Here it was column. We were deducting 40-40. But right now the case is beam. So you have to take beam one. Okay. Very simple. Okay. I'll go back to the drawing again. Okay. And then this will be your development length like this. This will be resting in the beam, okay? This is a development length. You can find this, no? That's it. Now you add all the length, you'll get the cutting length. Top I did. Similarly, bottom you're supposed to do. Got it, no? So top I did. Similarly, you do the for the bottom bar. Very simple. That you can do, no? Yeah. One case study we learned about if there is a beam coming, you have to detect the beam cover, not the column cover there. Okay, fine. Now in the same way, if you're going for GB2 beam, this is my GB2. So if this is my GB2, then I have a column here, I have a column here. In that case, you will detect the column cover only. Got it. But again, if you're putting a beam here, if you're putting a beam here, then here it is going in the column. So column 40 mm you will deduct. But this end is resting on this beam. So here beam column, beam cover you are going to deduct. Getting my point? But again, if you deduct both the side 40-40, it doesn't matter. I told 25 and 40, how much difference? 15 mm difference, nothing will happen on the side. Okay, 15 mm, nothing. I'm telling you the more accurate way. But if you feel, sir, we don't have to do so much accurate, no problem. Both the side, you take it as 40-40 and do the calculation. Nothing will happen. Okay, fine. So in this way, you're supposed to do the calculation. Okay, getting my point. But like I mentioned, usually we don't do BBS like this. I mean, we don't have to, comment. For that, we ask the AutoCAD draftman, give us the cross-section longitudinal view. And once he gives that, then we'll do like this. Okay, okay, that's how it. So I'll show you one more drawing. Yeah, we'll go for this drawing now. Look at this drawing. This is a good drawing what they have given. Check now. So can you do a BBS for this beam? Exactly, you can do it. Why? Again, for the very same reason, you know everything. For this, you can do. So the beam dimension is given 200 by 750. Good. Here, they have given 16 of 2 THO means throughout. So this beam is going throughout. Okay. This beam is going throughout. So what is the diameter? 16 of 2. You can find the cutting length, no? Your clear span is here, your clear span is here, and then this development length. Then the bottom, what they have written, 16 diameter 2 bar, it is throughout. Again, you will put 16 diameter 2 bar in the bottom. I'll take a different color here. So this is my 16 diameter 2 bar. This also you can find the cutting length, same thing. Okay, how you'll find the cutting length? You'll find the cutting length from here. From where? From this face. This much length will be a clear span. This is what you're supposed to find. How much will be this length? Very simple. These people have already given you 2250 plus 2224 plus 2250. If you add everything, directly you get the length. Finish. Now, remaining portion, whatever you have from this to this portion, from this to this portion, it's a development length. You have to check in the drawing what is the development length given. So, if the development length given is, let us say, 50 times the diameter of the bar, 50 into D. Accordingly, you try to do the calculation. What you will do? This length you will measure minus 1 cover. This is column, so minus 40. This length you will measure minus 50, minus 40 cover. And then this entire is development length. total development length minus this length, total development length minus this length will give me this L-shaped length. Understood, no? Very simple. Now, come to the bottom portion, same thing. Bottom also same thing. This much is clear. Done? Yeah. Now, other than that, this particular drawing has a top left extra. Where it is top left extra? See here, 20 dia 2 they have mentioned, no? EXT means extra bar. So this is your 20 diameter 2 bar which will go extra. So this will be your top left extra. Similarly, 20 dia 2 bar. So this will be your top right extra. So can you find the cutting length of this? Obviously, you know how to find because this length is already given. Is it? Yeah, this length is given. No, this length is 2250 from the inner side of your column to this. It is 2250. The size of the column, I don't know. I'll measure the size of the column from here. Okay, I'll measure the size of the column from here. You see, you can do all these things, but still I'm explaining you. Okay, I think by this time you should know all these things. So my size of the column is 775. From 775, I'll deduct cover of 40 mm from this side. Similarly, this is also 775, I guess. Okay, this is 726. It is coming. Yeah, 768 and all it's coming. Okay, it is 726. So 726 minus 40 mm cover will do. Okay, and then this will be a development length which will be given in the drawing. 50 times the diameter minus this answer. 50 times the diameter minus this answer will give you this L. Which one? This one. This one it will be giving. Okay, this we already found. Same thing. Same here also. This one will get total development length. Understood? No? Finish. Other than that, here one extra thing is coming. What is that? There's something called as bottom curtailment bar. What is that? You're listening it for the first time. I know that. You can see one more bar is coming here. So this usually comes, but in the previous drawing where I did the complete estimation, there you did not get such kind of bar. But practically, if you ask me, sir, where this bar comes, see here. So practically, this is that bar. Can you see one bar here? Can you see one more bar behind this? This is your bottom curtailment bar. What is that? Bottom curtailment bar. Can you not find the length of this? Very simple, straight bar it is. And in the drawing, these people are going to mention you that from here to here, it is this much length. And they are going to mention you from here 800 mm you have to leave. From here 800 mm you have to leave. In the total length, if you minus 800 from here, and if you minus 800 from here, will you not get this particular length? Very simple. That calculation you do on your own. It's very simple. I'll not teach you again because now you are grown up to that level where you can do it. Okay, fine. Yeah. Where was that? Yeah. So if you want, I'll do it for you. We'll do that calculation, not an issue. I want to find this length now. Let me find this length. From here to here, I'll find the length. So how do I find this length? It's very simple. I know that this is 2250, 2250 plus 2224 plus 2250. Do it manually and tell me how much it is. 2250 plus 2250 plus 2224. 6724. 6724 is my total clear span length, what I've got. In that, in that, this is in that, this is 950. This is 950. Because this bar is starting from here. This bar is starting, is going only up to this length. And this is 950 given. This is 950. This is 950 gone. This is 950 gone. So in this, if I deduct 950 and 950 from both the side, will I not get the answer? So what I'll do is, I'll do here only. Okay, now I'll do here only. I'll do here only. Minus 950. You know, no? Why 950 I've taken? This 950 if I deduct. And from here, if I deduct 950, try to do it and tell me what is the answer you're getting. In the answer, what you get? Minus 950, minus 950. 4824. 4950. 4824 mm. That's it. Simple. You got the cutting length. So the cutting length of the green color bar is 4824. 4824. Simple. Okay. And what is the diameter of the bar? It is written 16 diameter 2 bar. EXT means extra diameter. 16 dia 2 bar. In the Excel sheet, you have to prepare. In the Excel sheet, what you'll do, you just have to insert. For example, just in case if it is coming here, I'll add insert a few this thing here. Okay. I'll insert it. So I'll put a straight portion here. I'll go to the illustrations. Okay, anyhow, I'll copy the same thing from here. I'll copy the same bar. I'll say Control C. I'll just paste it here, Control V. Straight bar I got. What is the length of that? So length, you should do that manual calculation, but directly I'll put 4824. This is the total cutting length what I got. Keep it to the center. Restings can you do on your own? That's it. Finish. I'll do only up to here. Resting you write. How many bars are there? Two such bars are there. What is the diameter? What is the diameter given for us? The diameter is 16 diameter 2 bar. Finish. Right. 16 there. Right. 16 here. And okay, this is one number. Number is one. Okay. I mean, right now I'm considering one number. How many bar? Two bar. And this cutting length will be very simple. Just add this. Finish. This is in meter, mm, and you divide this by 1000. You'll get it in mm. And then total cutting length will be this length. If I multiply it by number, and if I multiply it by number of member, I'll get the total cutting length. And it's a 16 diameter bar. Put it in the 16 diameter column. If you do this one, no, now you have become expert in bar bending schedule. Other than that, this was the one thing which I had missed in the earlier case. Now we have completed. So this is a typical type of drawing that you get when you do the bar bending schedule. This much you understood? Finish. So this case also I've taken. I think now you can do the complete bar bending schedule. Finish. So in this way, all this drawing is given. You can do the BBS of this. So again, same thing. Here also that bottom curtailment will come. Again, now all these are continuous beam. You see this beam and all. Yeah, look at this beam. This beam is a continuous beam. Where, which one? This particular beam. This particular beam is continuous beam. Okay, it is starting from here and bottom. Okay, so you can do the continuous beam. Just add all the length, rest things you know. Okay, just in case if you have doubt, get back to me. I'll clear all your doubts. Okay, it's very simple. It's just a matter of addition and subtraction, and understand the concept where what has to be done. That's it. Finish. So this was the one building. This is the one plan I wanted to explain. I think other than that, rest all BBS you can do on your own. Still, if you get any doubts, always get back to me. Okay, fine. That's what it is. That's how it is. Other than that, in the next lecture, I'll take you a few more assignments. I'll show you one industrial building drawing. I'll show you one more industrial building drawing. And then there's one PDF which is with me. That is my assignment project I have. I'll explain you the BBS for this also. And I think that is enough. Okay. We'll do up to there. So once we do up to there, I think we have completed the BBS part completely. And there is one BBS where we need to understand that is a side face reinforcement. That is one more complicated BBS. And if you learn that also, I think almost all the BBS have covered. They will, okay, you'll get side face reinforcement. So I'll teach you that also, how it has to be done. So we'll see you back in the next lecture.